Welcome to Killer Cure. At Seed Healthcare, we're focused on identifying health risks early before they progress into chronic disease. Today, one of our guests, Leo Grady, is building one of the most exciting tools to do just that. He's had a journey in healthcare that really is exciting to hear about, and he has a combination of knowledge that I think all of you will really enjoy around the microbiome, the science, AI. We're going to go a lot of different directions. Also welcoming Bill Liao, my co-host. Leo, why don't we start with a brief introduction on your background and kind of get the audience excited.
Yeah, thanks, Todd. It's really great to be here. I did my PhD in AI over 20 years ago and specifically focused on computer vision. So my first part of my career was at Siemens, building AI for radiology, looking at MRIs and CTs. Then I was in the Bay Area for a long time at a company called HeartFlow, where we built a cardiovascular diagnostic test for coronary disease that was AI and computational fluid dynamics. And that turned out to be the first Medicare payment ever for an AI product in healthcare. Then I was leading a company here in New York called Page AI, which was a spin out of Memorial Sloan Kettering, building AI for pathology. So we were using AI to find cancer in pathology slides and had the first FDA approval for an AI system in that space. Then I was on the investor side for a little bit, working with Jim Breyer, helping him invest in AI companies in healthcare. And I started Jona about 3 years ago because I felt that the gut microbiome really afforded an incredibly exciting opportunity to make impact in healthcare.
Amazing. Your background really resonates. I mean, AI before AI, right? And you think about the ability to leverage the current technology advancements that we're having with computing power and all that, even just from looking at a slide, right, from Sloan, from a cancer cell, all the way through to now the microbiome. What was the motivation? Like your background to develop AI and that mindset, where did that come from?
I mean, how did I get into AI in the first place?
Yeah, go back to the beginning.
Well, my undergraduate degree was in electrical engineering and anthropology. And there's a very slim slice of the Venn diagram of those two things, which I really think AI fits into that. I started my PhD in '99, and it was a couple years before that IBM beat Kasparov in chess, Deep Blue. And so there was, a lot of people don't remember, but there was a lot of excitement around AI at the time. Everyone's going to lose all their jobs. If we can beat the grandmaster in chess, what's left? And so it was a really exciting time, but there were very few programs for AI. And I actually entered a program that was entirely focused on neural networks and using neural networks for vision, for speech, for language, for, basically motor control, everything that you'd ever want an AI system to do. And it turned out, neural networks at the time were very much like in the winter. And, the sort of expert system that IBM built was much more ascendant. But I really believed in the power of that technology and have been vindicated over the last 20 years as now all AI is neural network based.
That's amazing. So the journey from there to HeartFlow and the things that then became really tangible in healthcare. Were you always, AI and healthcare? Was there other applications, or did it just? And then I certainly want to hear how you got into the microbiome and when it became relevant to you and what really motivated that.
Yeah, I realized during my PhD, I went through in 4 years, I realized that academia wasn't for me. I didn't get a lot of satisfaction from publishing papers or having people cite my work or anything like that. I really wanted to build technology that could have a ton of impact in the world. At the time I graduated, there were really 3 application areas of AI. There was military, there was surveillance, and there was healthcare. And I had a job offer from Raytheon to go build the missile defense system and these things. But I was much more excited about healthcare. And Siemens was really incredible at that time because the group that I joined was in Princeton. They had 100 PhD level people with an AI background working on the hardest problems in medical imaging and image analysis, tumor finding, cardiac, ultrasound, OBGYN, really spanning the entire spectrum of medicine. And it was a really incredible time to be there, where we were really, really leading the field for medical imaging and medical AI development during that time.
Amazing. We talk a lot on this show about the advancements in AI and what's happened in imaging, particularly around heart, and heart flow is a conversation. And you think about that advancement and actually being able to measure the flow in an artery, without being invasive. We talk a lot about the CTAs and, the CT angiogram, and how that's actually helped heart disease kind of transform so that you don't have to be invasive to go figure out you have heart disease. And you can actually then work on work on the disease states. Being involved in that, heart flow was earlier than some of the new advancements and the CTAs, and the headwinds that you faced. And because that's, now we've got the whole movement towards AI adoption, but then it was still foreign. How did that happen? As far as your role as an engineering, person in that organization, how did you really drive that?
Yeah, I joined HeartFlow in 2012, and the founder of HeartFlow was a Stanford professor, and he had really pioneered biophysical simulation of blood flow. And he actually created the biomedical engineering department at Stanford. And all of his work was on how do we accurately measure blood flow, predict blood flow under different conditions, how does it perfuse into different tissue. And every time they would do their experiments in academia, they would basically take an image and have somebody like go pixel by pixel and measure everything. And so when they started at HeartFlow, that's how they started, but that doesn't scale, right? And so after, about 2 years, they realized that they needed like real expertise on doing this automatically. And so I had met the founder through a mutual acquaintance. And so he reached out to me. He was kind of trying to recruit me for a couple of years and eventually brought me on to really lead all of the AI development for extracting this information, as well as, and then I ultimately ended up leading all of product and technology. That it was an extremely difficult AI problem because, if you think about a coronary that can be stented, you can stent a 2 millimeter lesion, right? And if it's got a 50% blockage, then there's only about 1 millimeter of lumen that you see. The resolution of CT, at least at the time, was about 0.3 millimeters in the axial direction and about 0.5 millimeters in the Z direction. And so effectively, the lumen of the blood vessel was only represented by a couple voxels. And if you got it wrong by a voxel, you could completely shoot the accuracy of the blood flow stimulation.
I think that the audience might like to know that term and what it means.
The lumen, or which?
Voxel.
Voxel. So when you take a CT image or an MRI, it's a 3D image, right? And it's cut up into little cubes, and each of those cubes has a certain value. Usually it's not color images. In the case of CT, it's what's called in Hounsfield units. But those little cubes are called voxels.
Yeah, they're little pixels.
Exactly. So in a 2D image, you're cut up into little squares. Those are pixels. In a 3D image, you're cut up into little cubes, which are called voxels.
And when you look at the changes in the number of pixels in an image these days, it's just vastly bigger than it used to be back then. And you would have to say that the number of voxels in an image has also vastly increased, would you not?
It's getting bigger. Not at the same resolution as optical cameras.
No.
Your typical cardiac CT is going to be 512 voxels by 512 voxels by maybe 450 slices, depending.
Yep.
So it's quite a bit of data. It's about a gigabyte typically.
Yep.
You have to contend with the fact that there are multiple different scanner vendors, multiple different reconstruction protocols. Different hospitals will prepare the patients differently. Some hospitals have, obese patients or thin patients. And so there's a lot of variability there that you need to control for when building this AI. And it has to be super precise all the time.
And back then, with the lower resolution images and, the time sequence, while it was unscalable, a human could actually do it. right? If they knew what they were doing, they could slowly go through voxel by voxel and kind of figure it out, right?
Yes, I mean they can,
Well,
but
could, I would say could.
no, they can,
Yeah,
they can, but doing it accurately is difficult even for humans.
yeah.
So
And today, though, with the amount of data that we get out of things, it's no longer possible for a human to figure it out, isn't it? In some things, like
with enough time and the right tools, they can do it, but it's certainly not scalable.
yeah.
And
When you
probably
look
not
at like a large language model, though, which has ingested so much data, the time a human would take to even understand the model's probably longer than a lifetime now, right?
It's true. I mean, it's interesting though. I mean, large language models today clearly work very different than human brains, right?
Oh, yeah.
I mean, you can have like a 2 or 3 year old that can speak pretty reasonably well. They haven't ingested anything like the entire internet,
Yep.
and yet they're able to speak, they're able to formulate new sentences, they're able to generate with much, much less training data. So whatever we're doing mentally with human brains is still quite different than how LLMs work today.
It's also a lot more energy efficient, isn't it? I mean, you feed a toddler a jar of baby food and they'll do that all day, right? Whereas, a single ChatGPT session is going to use up a lot more energy than you'd find in a jar of baby food, right?
Yeah, it's true. And I think, what a lot of people don't appreciate that this was really a trend even before LLMs. In my area, which was vision, there was a breakthrough back in 2012 with a contest called ImageNet and a particular algorithm called AlexNet, which really showed for the first time that neural networks could significantly outperform other types of approaches in image analysis.
I remember.
Yeah, and it was really amazing. But a big part of it was the ability to feed in a tremendous amount of data.
Yep.
And the part of the key was that neural networks don't really asymptote in the way some of these other techniques do. And so as you feed in more and more data and you have the compute power from GPUs, you could start to do things with neural networks that were just not possible before.
Yeah.
Through like in that period in the 2012s and then, subsequently, we finally had enough data pulled together and enough of that compute power that we could really solve problems in vision that we hadn't been able to before. But to your point, it's way less energy efficient than biological systems were.
At the same time, though, you're right. I think people also underestimate just how far we've come with the compute. Like people go, LLMs came out of nowhere. No, they didn't.
No.
It's just that our compute is still increasing almost exponentially. And I've just seen some recent developments that mean that Moore's Law might even continue.
And I have to say, I was surprised by how successful the core training of these LLMs was by doing next token prediction. I mean, if you had asked me prior to all of that work, just predicting the next word, the next phrase, is that going to allow you to build something like ChatGPT? I would have said no.
Yeah.
It's not at all obvious to me a priori that that's going to work, but it works phenomenally well.
It does, although I would argue that no human actually understands how it works.
Yeah, I think that's absolutely true. I mean, we understand the architectures. We understand some things about the system, but to a degree that they are absolutely black boxes.
Yeah, and because of the amount of data ingested, like the decisions that it's made out of the data ingestion, the tokens that it's prioritized, et cetera, it's more than a human's lifetime to go and tease that out.
It's interesting to think about if we don't know how it's doing it, and everybody talks about like the risks that we have. And I don't know which side of the camp you're on, Leo. You've been in it for a tremendous amount of time, longer than most humans have actually been talking about AI, right? So you start thinking about that. Where do you sit on the risk side of AI? And I've had one side of the table says, oh, I'm going to go get a bunker and I'm going to be hiding somewhere and all this stuff, all the way to the other side, which is, let it happen and let our, the drivers of where we go. Where are you on that?
Yeah, I'm very much on the side where I think people have overblown risks. And I feel like, yes, certainly, this is powerful technology. And like any powerful technology, there are ways to abuse it. There are harms that can come from it. But when I think about some of the rhetoric that I hear in the media or with some people in the field, it seems very short-sighted, both in two ways. One is it seems to lack a historical understanding of how technology gets adopted in general, and there have been a lot of other disruptive technologies that have not ended in disaster. And secondly, the scenarios that get painted for widespread destruction, I think, are completely unrealistic. I mean, just taking the paperclip concept, which you guys are probably familiar with. I mean, the whole danger there is presupposed upon the idea that there's a single AI in control of all the world's resources that can do whatever it wants, and that it's marshaling all of those resources to make paperclips. It's ridiculous. I mean, there's no way that every government, every power company, every corporation would sign over control to some one single AI that was uncontrolled. It's completely impractical to even think about a scenario like that.
Yeah, I mean, I totally agree. The idea of the fear at the base of most anti-AI stuff and the things that terrify people are either cinematic fantasy or just badly thought through. At the same time, the unintended consequences of AI are serious and real, and people are dying and have died because of the unintended consequences and mismanagement of AI. It's just not the AI doing it. It's just basic stupidity, usually, or greed. Greed is a tremendously powerful way of...
You could make that argument about any technology. I mean, take automobiles, right?
Yeah.
People die, 20,000 people die in car crashes in the US every year. Certainly displaced people that were, operating horse stables and making horseshoes and all these sorts of things. And it definitely restructured how we develop cities and how we work and live. At the end of the day, I don't think anyone wants to go back to horses.
I don't think, well, I know plenty of people who do. At the same time, that's not what I'm advocating for. I'm also not making that argument. That's a different argument. The argument I'm making is that it comes back to an old joke, a human being can make, I don't know, 2 or 3 mistakes a second. To really mess up takes a computer. It's the unintended consequences of direct greedy actions that aren't controlled that have caused more damage in recent times. And it's just the speed at which the mistakes can be made and the difficulty of putting Pandora back in the box. So I'll give an example previously of the Facebook optimization algorithm in Myanmar bringing attention to a certain type of racial disparity, which then ended in the mass slaughter of a lot of people. And that could have been foreseen and changed. It's just nobody paid attention. Like, it was just stupid. So all I'm saying is that there are real dangers. They're just more, from my perspective, kind of dangers of greed and negligence in the application rather than any inherent issue with the technology. And to Todd's point earlier, like riffing off, we don't understand how it works. We don't understand how most of physics works, and yet we use it every day. And occasionally we make atom bombs, which is, we don't fully understand how they work either, but they're not good. Most of the time we make light bulbs and, self-driving cars.
There's a lot to that conversation. I think we could spend a couple hours on that. But I want to actually shift just for 1 second, because all of the things that we're talking about, like the risks, I want to talk about the opportunities. And you shifted your career to some degree deep into healthcare. You went from heart, to the lab, and the science around images, all of those things. And now the microbiome. I want to get back to like the opportunity ahead. The opportunity ahead is, what are we discovering with all of this, and how is it really affecting us, in a positive way versus the death and destruction side of it all. So let's maybe start there with that journey, if you don't mind.
Yeah, I appreciate that. When I look at the most exciting areas of healthcare, they're incredibly complex. Genomics, transcriptomics, RNA sequencing, the gut microbiome. And I think it's very, very difficult I mean, we know these ways of measuring biology have a lot of insights into someone's health and also into what the best treatment's going to be for them. But when you show a doctor a big long list of genomic alterations or somatic alterations or transcriptomics or proteomics, they have no idea what they're looking at, right?
Yep.
And I think that parsing that data and making sense out of that data is very difficult. However, the science is moving very fast in these omic areas. And I think we have this real opportunity for the first time where we can apply these language models to extract information out of the literature and then apply that to analyze these incredibly complex omics data sets that can provide really evidence-based, unique insights into human biology, as well as into optimal treatment paradigms. And so at Jona, I felt that the best opportunity here was actually in the gut microbiome. And the reason is because every aspect of our health has been linked with the gut microbiome. So it's not just gut health, it's obesity, it's food allergies, it's skin disease, Parkinson's, Alzheimer's, depression, even cancer. All of it's been linked with the gut microbiome. And yet the gut microbiome is probably the most complex omics that is out there, especially when you do shotgun sequencing and you really get into what's going on. And the reason for that is because there are more than 11,000 different organisms that have been linked to health in the literature. And yet any one individual maybe has 300 of those 11,000 organisms. And so it's, from a sort of like a math standpoint, you can think of these as very sparse signals. Like most organisms you have zero of, but you have some subset, and your subset is has generally very little overlap with someone else, right? Like you and I share 99.5% of our genetics, but probably only about 10% of the species in our microbiome. So you have this incredibly sparse signal that is completely central to your health. You have literature that is growing at 2,000 studies per month, almost 3,000 studies per month. And it felt to me, and we know also that the gut microbiome not only impacts health, but impacts treatment efficacy. And so what we did at Jona is we built an AI system to read all of those studies, more than 200,000 studies in PubMed. We offer this gut microbiome test. It's a stool sample. You send it to the lab. We do deep metagenomic sequencing on it. And then the AI matches the patterns, basically goes study by study in the literature and looks for these patterns, looks for these signatures, and pulls out whether your gut microbiome is linked to Crohn's disease or bloating or Parkinson's or whatever it is, more than 1,000 conditions. SIBO. And then we go a step further, and the AI reads all of the interventional literature. And so we know there are more than 4,500 interventions that have been shown to change your microbiome. So then we can say, what happens if you go vegan, right? And we know from all these studies that going vegan changes your microbiome in a certain way. And so what we can do is we can simulate that and make a digital twin of your gut and make like a virtual vegan version of you and see, is that going to help you resolve some of these disease associations? And then we can do the same thing with keto and gluten-free, and digitally, virtually, we can give you every dietary change, every lifestyle change, every supplement, every drug, really figure out what's going to be optimal for you. And this is the kind of thing that there's no way any human being can do by reading 2,000 studies a month, by looking at this incredibly complex data. It's only with AI that you're able to pull together this data and then do the simulations to figure out what to do next.
When you sequence someone's microbiome, how much data do you actually generate from that, just from the sequence?
About 8 gigabytes.
8 gig, yeah. So compare that to the old analysis of your heart. It's 8 times or more data.
That's right.
that you're churning through. 8 gigabytes is roughly the entirety of Wikipedia, just so people know.
Yeah.
Right? There's a lot of information there.
Yeah, I mean, I'm glad you brought that up because it is an incredibly data-rich environment. And to your point, yeah, it's 8 times what you would get out of a cardiac CT, which is a 3-dimensional, CAT scan of your heart. you get 8 times that information just from a single stool sample when we do the sequence.
Yeah, it's totally incredible. And again, if we didn't have the compute, it would be totally useless. Like literally just 10 years ago, if you handed somebody an 8 gigabyte file and said, hey, do something with this, they'd just laugh at you.
Yeah. Yeah. And even just a few years ago,
Yep.
trying to extract all of this information from the literature in a way that was repeatable, that was accurate, and then operationalizing that to analyze this data would have been impossible. We really had to break ground.
Totally impossible. And yet people are like surprised that we've got all this new tech now and they're distrustful of it. I remember a few years back, the majority of physicians out there, gastroenterologists, would have denied that SIBO even exists.
Really?
Yeah. Like it was like fairly new in the literature and most people would be like, really? Nah, that's just, yeah. And even to this day, I know, especially women who've gone to GI doctors and with the exact symptom set and have been prescribed tranquilizers, like sedatives and Valium, because oh no, that's not a thing. Whereas there are, of course, now doctors who will go, oh, that's SIBO, and even if you figure that out, finding the right intervention, because SIBO's multiple pathways for cause, right? So I noticed in the literature the other day, because I work with a couple of other microbiome companies, that people taking GLP-1s, when they have SIBO, the GLP-1s can stop working or may not work in the first place. And if you consider that just with GLP-1s, Novo Nordisk is generating, I think it's a third of Denmark's GDP.
Yeah.
I think it might be higher.
Yeah, it's probably higher. It would strike me that Jona, even in just that tiny slice of the market, quote, cough, cough, tiny, that has gastrointestinal issues, just by understanding that better, you could make GLP-1s work better.
Well, it's true. There are actually studies that have looked at this, and GLP-1s don't work for about a third of the people that take them. And there are a number of studies that have shown that your pre-treatment gut microbiome is highly predictive of who's going to respond to a GLP-1 and who's not.
Yep.
And it's not just GLP-1s, it's immuno-oncology drugs, biologics, SSRIs for depression. Your pre-treatment gut microbiome has been shown to be highly predictive of drug efficacy across wide classes of drugs.
Absolutely. It just happens to be that, if you can increase Novo's market share by a third, that's not an insignificant amount of money.
No, I think they'd pay pretty well for that.
Yeah, so, I know at least one of my other fantastic companies in the space is making some good traction there.
That's great.
So when you think about it, information is power, right? When it comes to healthcare. And, what you're talking about is taking all 3,000 published articles, distilling it down, allowing the data to kind of be the driver of the outcome. You're then taking the science and detail of what's in the microbiome and unpacking that, and then correlating it. I mean, there's a lot of work done there, right? You spent, since we met, back in 2021, I believe, you've had a journey of putting all that together, and now you're able to do that repeatedly at scale. And to me, that's like, you took a very short time to do that. And now you think about where we're going. What's going to happen with the data? What do we not know about the microbiome and how it relates? And then what's going to happen? What's going to continue on? And what should somebody that doesn't know any better do with this data, right? I think that's, we have all different kinds of listeners, from my 82-year-old mom all the way through to people that actually understand AI and science and genetics and mRNA and all the things that go into it. So I think that's a long way to ask, where does this go? And what do we learn in the upcoming number of years? And how does the patient use it?
There are a lot of ways that we can leverage all of this data. Here are a couple of them. One is to actually go from literature-based correlations to actually diagnosing people. The signs show that you see, or that the studies show, you see early signs of Crohn's disease, early signs of colon cancer, early signs of Parkinson's, early signs of fatty liver in your gut microbiome, sometimes years before you see symptoms elsewhere. And if we're able to, and even pancreatic cancer, as well. And if we're able to go beyond, hey, this is a signature for Parkinson's, to this is a diagnosis of Parkinson's that is happening way earlier than you would otherwise get. And this becomes a screening tool for the population for a whole panel of different diseases. The data that we're gathering now will allow us to actually build that case to see what's possible in terms of doing early diagnosis for a whole range of different disorders. Another aspect of using the data is what we were talking about before with drug development and drug efficacy. Because if we can determine that your pretreatment microbiome is going to impact the efficacy of an SSRI or an immuno-oncology drug, and it's causal, then what that means is that we can change your microbiome before you go on these treatments to actually increase the efficacy of these drugs. And so you can really imagine a whole world of microbiome adjuvants that would go into helping improve efficacy of drugs. You can also imagine a world of companion diagnostics where we say ahead of time, you're not likely to benefit from this drug, so try another. For example, with a lot of inflammatory bowel disease drugs, doctors generally have no idea which drug to give somebody. And most of the decision is based around, well, is it an infusion? Is it oral? Is it whatever? And kind of the patient preference. But what we know is that the first drug somebody gets is likely to be the most effective. And so if we can actually build a tool that says, for this person, this drug is most likely to be effective, that can really change outcomes for people with inflammatory bowel disease. And I think the last way I see us being able to use the data is with more longitudinal data, getting a better understanding of changes that people have made to their diet, changes that people have made to their medication or their supplements. It allows us to go beyond the literature and start looking at what lifestyle interventions, what real world interventions are having the most impact for somebody. And as we track this over time, again, we can start to see early signs of potential disease, potential harm, and help somebody course correct before they get into that place.
And do you think instinctively, or using your gut instinct, that we're going to find the...
Here, so that's a dad joke, Bill. I'm going to call you out on that.
Of course. Do you think that, and my kids will be proud, that we underestimate where the arrow of causality is pointing in, especially at these early stages of disease? Like, presumably, if we get to a point where we can detect Parkinson's years before it ever shows up, and by the way, there's very good evidence for that. There's that lady who can smell Parkinson's, I think it's a decade in advance.
Being able to smell Parkinson's early as well.
Yeah, there's actually a human case,
right?
And it was a really fascinating story where she could smell. Her husband had Parkinson's, and he had a particular smell that she noticed, and then she found it on other people, and she had 100% diagnosis success. And in the clinical trial, one person that she false positived, she actually met 5 years later, and he at a Parkinson's conference where he said, "Oh, yeah, I actually developed it." So. So if you catch us super early, one wonders if the microbiome change is just a reflection of the disease state. So what's your instinct on whether at that early stage the microbiome is just a reflection of a disease state caught early, or is it the other way around? Are there microbial dysbioses in our gut that are very subtle and work over a very long period of time that actually the causal action is the other way, and maybe you could shift the microbiome and therefore prevent the disease?
Well, the first thing I'll say is that even if the microbiome is just a reflection and it's non-causal, the value as a diagnostic can still be very high, right?
Absolutely.
Even if we discovered that there were shifts linked to Parkinson's disease very reliably that were not causing Parkinson's disease, but we could detect those early, that is a huge win. One of the best tests or most common tests for colon cancer is blood in the stool. Blood is not causing colon cancer. When you treat colon cancer, you're not treating the blood, yet it's still a very, very effective test. So the first thing I would say is that whether or not the microbiome is causing any of these diseases, there's still a ton of value in looking at them as a diagnostic or an early stage.
Completely agree.
As far
I'm
as
just asking for your instinct on
yeah,
intervention potential.
right. Well, we don't always know. There are some cases where we do have a good sense of causality and cases where we don't. My view or my instinct is that the gut microbiome is causal quite a bit more often than people think.
Yeah.
And if I look at kind of around the spectrum here, that, for example, with Parkinson's disease, that it really seems to start in the gut. And, people used to do vagotomies where you cut the vagus nerve. Turns out that if you cut the vagus nerve, you don't get Parkinson's. You have all sorts of other issues.
Yeah.
But you don't get Parkinson's.
Yep.
And so it definitely seems that it starts in the gut, travels upward to the brain. With things like depression, anxiety, many mental disorders, we know that diet can have a huge impact, really huge impact, equal to or exceeding the impact of many of the most common drugs. And that's not necessarily a microbiome change, but certainly the microbiome is going to be impacted by those drugs. And we know that there are telltale signatures for a wide range of mental health conditions linked to the gut microbiome. We also know from microbiome transplants, fecal transplants, that you can take, you've probably seen this, like the obese mouse and the thin mouse, and you take the stool from the obese mouse, you put it in the thin mouse, and they blow up and they get fat, even though you keep their diet exactly the same. And then you can go the reverse. You can take the thin mouse microbiome, put it in the fat mouse, keep their diet the same, the fat mouse slims down. It doesn't seem to work quite as well with humans, but there are certainly a number of stories of people who've had fecal transplants where they've had a permanent weight change that matches the donor in a way that they cannot seem to shake, even though their diet more or less hasn't changed. So we know that, stool transplants can be, almost miraculously curative in some cases of ulcerative colitis, Crohn's disease, wide variety of disorders, even psychiatric disorders. But it doesn't work for everybody. I think what that points to is that there is causality here. We don't fully understand how to analyze somebody's gut microbiome, and we don't fully understand what state we're trying to get it to. But if we are able to understand those things, I think there's a real opportunity to, in many cases, cure some of these diseases.
I completely agree. I noticed too that there's a lot of work coming up in tumor microbiome. And I also noticed that there's a decent piece of work from Japan on the role of soil microbes in reversing depression. Because people who garden with bare hands, they noticed have a lower level of depression. And they actually tracked it down. I forget the name of the microbe. It's tracked down to a single microbe that actually does penetrate skin.
Wow. That's super interesting.
Go ahead, Leo, please.
Oh, I was just going to say, I mean, I think what a perspective that a lot of people forget about is that we evolved in a sea of microbes, in a complete ocean of microbes, in soil, in air, in our food, when we eat things, and in our gut. And as humans evolved, as every living organism evolved, it's really evolved in that context, in that milieu. And so our body is completely adapted to this sea of microbes and actually relies on these microbes to produce all sorts of metabolites that we can't produce on our own, to break down foods that we can't break down on our own. And it's a really essential part of human development. So whether it's in the soil or, in your food or in the air, our body is really evolved to operate well in that environment.
And many microbes have evolved to operate well in our environment.
Exactly.
You could almost argue, though, that every single human cell has a microbe guest, being the mitochondria.
Yeah.
And those tend to get shut down in cancer. So, the healthiest of cells tend to have pretty healthy little tiny mini microbes in them, giving them all their energy.
So it's actually, so on the science, we all agree that catching these diseases early, if you can do it with the microbiome, that's a big indicator. You and I, Leo, have had mutual friends, and one of our board members actually go through a discovery of why he'd been having headaches for years, right? Like for most of his life, right? And they've significantly reduced based on changes in his diet. And that was related to the idea that the Jona test, the baseline of where you are today, actually found some things and gave some prescriptive ideas around diet change that would enable change. So to me, we're talking about the future, right? But we're also talking about, what do you do today? What can we do today? And I have a battery. People ask me all the time the battery of tests that I have every year. I have heart disease in my family. I have cancer in my family. It's not like, all of that's not chronic, but the idea that you have the history, you have genetics, you have all those things, and then you have a data that's available today that wasn't available before. And Jona is one of the tests that I prescribe to every year, right? And to me, what should somebody do, as a baseline? You start talking about GLP-1s, SSRIs, the efficacy of drugs, and what can be done both from a genetic perspective and from a microbiome perspective. How does somebody digest all this and say, what should I do every year to determine the best path for me?
Well, Todd, I'm very similar to you. I mean, I do full body MRI every year. I do, extensive blood work. I do my microbiome. All of that is, I think, just table stakes to check in on your health and get ahead of issues that, could develop. As far as your microbiome goes, what we see is that there are three different classes of people who come to us. There are people like you and me that want to do a checkup, want to make sure that everything's okay, if there's a problem, to get ahead of it before it turns into anything serious. But most just want to do a checkup. Then there's a second group of people who have some health issue. Maybe they have a diagnosis, maybe they don't. They're looking for a root cause and they're looking for solutions. And there are a lot of people that fall into that category. As you mentioned, one of our colleagues had severe migraines. We were able to identify a root cause within his microbiome and provide steps for changing his microbiome to move him away from that migraine signature. And there are a lot of people, we see the full spectrum: psoriasis, eczema, fatty liver, Crohn's disease, colitis, et cetera, et cetera, et cetera. Chronic fatigue syndrome, we see a lot as well. And then there's a third group of athletes, biohackers, the med spa world, people who want to look better, feel better, perform better, who aren't looking to solve an issue that they're having, but what they want to do is take their health to the next level. And for them, Jona offers an opportunity to optimize their gut, optimize their microbiome. With athletes, gut issues are the number 2 health issue that they have, often from overtraining. And we can offer them an opportunity to actually enhance their performance. So those second and third groups, people who have issues, athletes and biohackers, they tend to do Jona more frequently so that they can really track that the interventions that they're making are working and make adjustments as needed.
And how do you democratize this? Because there's quite a lot of logistics involved, quite a lot of processing involved. Last time I looked, there's about 1 billion people on planet Earth with GI issues right now.
Yeah.
And I'm pretty sure that you don't have 1 billion customers. And so, how can you democratize this? Is it a matter of refining the signatures and making the test easier and simpler so that you have individual tests that are much cheaper? Or is it more compute? Or is it better logistics? Or is it a combination of everything? And is that even the intention?
Well, we want to make it as accessible to as many people as possible, of course. To your point, within just the US, there are about 70 to 80 million people who have GI issues, not to mention all the other things that the gut microbiome is related to. We started with a cash pay model where people can order Jona through a provider, whether it's a concierge medicine, functional medicine, longevity provider. We also make it available for anyone to order off our website. So it's accessible in that sense, but financially it may not be accessible for some people. And ultimately, as we move toward early diagnosis, toward those screening applications that we discussed, then ultimately insurance is going to pay for it. And that will make it much more accessible to a larger group of people. Currently, we're only operating in North America and in the US and Canada, but ultimately we intend to expand globally.
That's a great question. The democratization is important to us. When you think about it, most people don't even know that autoimmune, where it comes from. You think of all the litany of disease states that can be interpreted from the microbiome data and where you could go. I just think it's a hugely impactful opportunity that is low cost as far as relative to more invasive diagnostics, like an MRI is more expensive if you just correlate what you do. And I fit in that category of proactive, the category 1, and maybe a little bit in category 3, because biohacking in that world, you want to optimize yourself and have a healthy lifespan. I think that's what we all want to do. So just in essence of time, I want to be mindful for everyone. We have a number of rapid fire questions that we're going to ask you, and it's not to drill you. It's just quick answers, and that type of thing. And there's so much interpretation of the microbiome. What's one thing that people get wrong about it?
That everybody should be taking probiotics. There are a lot of probiotics that can be helpful for certain people. The probiotics industry markets it as one size fits all, and many of the organisms in probiotics can actually are associated with negative things, negative health conditions when they're too high. So I would really encourage anyone to test their microbiome and get probiotics that are right for them, if at all. I personally don't take any probiotics because my gut microbiome is fine and doesn't require any.
That's a great tip, because one of the things that we like to demystify is supplements and how they fit and all of those things. And we all spend a lot of money trying to get the right things in our body. Right. And if we already have it, like a GLP-1 is a expensive drug, and we produce our own GLP-1, right? If it's all working properly, our microbiome does that. So that's a great tip, and I agree on probiotics. Off this recording, we were talking briefly about a recent, health experience you had, right? And one of them that I know people talk about is all of the things that can happen when you have an event. Your body changes when you have any of the antibiotics or any treatments like that. Is that a flag that people should look for and say, hey, we need to really be careful around that? And what is your thought on that? And what should they do? Is that when they get a Jona test? Oh, I've had a repetitive this, that, or the other. What's your thought?
Yeah, to your point, I recently had pneumonia and I got secondary sepsis, and I ended up having to take multiple different antibiotics. And, I think that antibiotics probably saved my life, in this case. And they're truly incredible tools that we have in medicine. At the same time, I think they're often overused for people that don't necessarily need it, who have a viral infection or have a sniffle, and they want to walk out with an antibiotic, not understanding the risks that come with it. There have been a number of studies that have shown that the number of courses of antibiotics you go through in your life are highly correlated to obesity, to a whole variety of different chronic diseases, and particularly if you're getting these antibiotics as a child. So obviously, in my case, I needed the antibiotics. I took the antibiotics. There are many cases where people do need them. However, I would caution against taking them casually. And when you do take them, especially the first 2 weeks after you are done with the microbiome, or with the antibiotics, your microbiome is in a very fragile state. And as a result, you need to be very, very diligent about the way in which you're eating. You want a lot of soluble fiber. You want to avoid sugar. You want to avoid processed foods. And doing that will allow you to reconstitute your microbiome in a positive way. I can't tell you how many customers we've had at Jona where they say, I was healthy my whole life. I had a root canal. I took severe levels of antibiotics, and my health was never the same after. And I'm trying to figure out what the root cause is and what I can do. We hear that every day.
That's a key tip. I would tell you the conversation around food is medicine. You think about that, and if it all really does originate in our microbiome, that has to have our gut and how we process enzymes we take out of it. It's super compelling. That's why we're 100% behind you in this. Speaking of that, is there a food that you would never eat after diving into your microbiome again? I know we talked about processed foods in America, Europe versus wherever, but what's the one thing you cut out?
Well, you're resilient to little blips, right? I mean, you can have little amounts of poison in many cases, and you're going to be okay. Alcohol, all sorts of different things. So there's not something that you're going to eat that's just going to destroy your microbiome. It's really about repetition and chronic use. If you are chronically eating highly processed foods, if you're having a ton of sugar, if you're not having vegetables, if you're not having soluble fiber, then over time, your microbiome is going to turn in a really negative direction over the course of maybe 4 to 6 weeks. And so you need to be aware that yeah, sure, it's fine, have a piece of cake or whatever, but you have to have your default in a much more healthy eating habit so that your microbiome stays in a good state.
That's a good tip. I think we all subscribe to that and try to be consistent. But always we want to live too in the same breath.
Of course.
So finish this sentence. In the next 10 years, the microbiome will
emerge as a new area of medicine and a new specialty that branches off of GI.
That's the way it should go based on what we know today and where things are going. What you've done has been amazing.
I'll actually even go further, and I'll say that the gut microbiome testing is going to be more important than blood work.
That, my friend, would be quite a leap, right? I mean, when you start to think about the correlation between blood and the body, I think but I think it's definitely doable. I think you're spot on. The data that you're providing out of a Jona test, which I've had, is incredibly valuable. It has been to me. When I think about the journey and innovation happening in healthcare, I put this as in the top, few, right? Like there's things that we just couldn't do before. And that's the exciting part. And really, there's a couple things. One, I want to thank you for coming on. And I know Bill and I both are grateful for your time. But two, I want to make sure that the audience can actually look up Jona. We'll put it in show notes and all that, but maybe tell people how to follow what you're doing and the progress and where they could get a test even, right? If that's what they want to do.
If you'd like to try Jona yourself, you can go to our website, jona.health, and you can order directly there. We're also on all of the socials, Instagram, Facebook, LinkedIn. We have a blog, a newsletter, so you can definitely follow along. And we really try to put out a lot of educational content that you're not going to see anywhere else on the microbiome and health. So we really encourage anyone who's interested in this space to follow along. And I think you'll find a lot there that's going to be helpful and interesting to you.
We will share all of that in the show notes and make sure that it's available. I mean, from a seed perspective, from what we're doing, preventing disease instead of just treating it is a key. And in order to do that, we need better tools. And that's exactly what you're doing. It's a better tool than we had, a year ago and the year before that and the year before that. We're getting there, and that's what we're really excited about. For all the listeners, subscribe to the podcast. We have more incredible guests coming, and our next guest will be Dan Pewter. Really, the last question I'll leave with you is, who should we have on next?
I think in the world of AI, I think some of the most exciting work right now is being done by Chris Mansi at AI, also Andre at Artera. And, I'm really excited about what they're both doing with their companies. They're much further along with their FDA approvals and their market penetration, but they've done a really masterful job in building those companies.
Beautiful.
Awesome.
Well, we really appreciate your time, Leo, and we hope the audience enjoys it and learns something. I always do when I talk to you. It's an amazing time in medicine, and we like the progress. So congrats on what you're doing. Keep it up. And thanks again for joining.
Thank you guys so much. This was a lot of fun.
Thanks, Leo. This was great.